This example asks us to approximate the area under f of x equals x squared minus 1 on the interval from 2 to 4 with n equals 4 rectangles. And then for part A it says use a left Riemann sum, and for part B use a right Riemann sum. Okay, well it's always helpful to start with a sketch so we can work off that rather than trying to do this all in our heads. Well, note that this function is the parabola x squared shifted down 1 unit. So here I've drawn a simple parabola, only the right hand side of it, and I've shifted it down 1 unit. Why only the right hand side? Well, we're only interested in this interval from 2 to 4. So let's draw in that interval. So we have 1, and then maybe 2, 3, 4. So let's start with part A and focus on the left Riemann sum. So that means we'll use the curve to find the height of our rectangles using the left side of the rectangles. So let's work on the bases of our rectangles first here. We have the interval from 2 to 4 using n equals 4 rectangles. So we need to squeeze 4 rectangles in there. So, well, not entirely trivial, but still doable. So we have little subdivisions in there at the half marks. So let's make this clear. This is 2, 3, 4, and then we have 2.5, 3.5, which I won't label in there because that'll completely destroy my graph there. Now we're going to use the curve to determine the left side of the rectangles. That's what's meant by left Riemann sum. So here at 2, we're going to go up to the rectangle, and then over and down. There we go, something like that. And then we'll do 2.5, use that to go up to the curve, and then over and down, get this rectangle. And then 3, we'll use that to go up to the curve, and then over to 3.5 and down. And then at 3.5, we'll use that to go up to the curve, and then over and down. Okay, so something like that. Hopefully your sketch looks better than mine does. Those rectangles are all supposed to be the same width, but I think you get the idea here. So then for part A, we have the area equals, well, the base of the rectangle 1 plus the height of rectangle 1 plus the base of rectangle 2 plus the height of rectangle 2, and so on and so on. Note that we can factor the base out. So I'm going to do basically base, and we'll do this from here on out. We'll always factor the base out. The height 1 plus height 2 plus height 3 plus height 4. Well, those are determined by the function. So note that the base is 1/2. We can see that from our picture, but let's get a little bit more of a mathematical grasp on the base. Remember, the base is determined from this delta x equals b minus a over n, where a and b are the endpoints of our interval and n is the number of rectangles. So in our case, delta x is 4 minus 2, those are our two endpoints, all over n, 4 rectangles. Well, that's 2/4, which is indeed 1/2, which is what we see, right? We're going from 2 to 2.5 to 3 to 3.5 to 4. So 1/2 indeed is our delta x, or our base. Okay, so this gives us area equals, we decided our base was 1/2, and now to get our heights, we simply plug in those points. And we're using a left Riemann sum, so we're only going to plug in the x values for the left endpoints there. So here we go. To get the height, we do f of, where's our starting point? 2. And really the first one is probably the most important one, because then you can deduce the rest from there. So we're using left endpoints, so we start with 2, and then take that to get up to the curve, and back down. So we'll do f of 2 plus, the next one is f of 2.5. The next one is f of 3. That's our next height. And our final height is f of 3.5. Okay, from here we can either put this into a calculator or set up a function on Desmos and grind it out that way, or any other program. There's a lot of ways to compute this. But one way or the other, this comes out to 13.75. My question to you is, Is 13.75 an overestimate or an underestimate? Indeed, it is an underestimate because we're trying to estimate this area under the curve, and those rectangles are leaving some space right left. So these are going to come up a little bit below the curve. Let's try it again using a right Riemann sum. Okay, so we're still looking at the interval from 2 to 4, but now instead of starting at 2 and going up, I'm going to start at 2.5 and go up and use my rectangle that way. Note that that's going to get us above the curve and back down like that. Okay, so let's draw in all our rectangles as best we can. So I'm going to start at 2.5 there. Okay, so that makes one rectangle, goes a little over. And again, I apologize for this not being quite as lined up and straight as it could be, but you know what, it does the trick. Gets the point across. We're going to let this go to an infinite number of rectangles anyway, so you just kind of do the best you can here. There you go. These are strange looking rectangles, but you know what, they'll work. Well, this one goes way at, wow, that's terrible. Thank you. So the 4 is just going to go up so high, I don't even think it would catch it on the screen here. Maybe way up here. Something like that. Okay, so that's going to really go up, but it doesn't matter. We'll catch it when we go in to evaluate the function here. Okay, so we're on to B, and the area is now same base, 1/2, so we don't have to redo any of that. And now we're using the right endpoints. So again, it's always the first one that's the most important. And did we start at 2? No, we didn't. We started at 2.5 this time around. So that's how we got the height of our first rectangle there. We started at 2.5 and went up and got this height. Okay, plus, and then we just kind of step from one endpoint to the next. So the next one is f of 3 plus f of 3.5 plus f of 4. Okay, so still have 4 different rectangles, but it's going to give us a much different estimate. Put this thing into a calculator, into a program of some kind, we get 19.75, which is now an overestimate. Okay, so what are some things we could do to get a better estimate? Well, in this situation, maybe if we used midpoints instead of the right or left endpoints, that would give us a better estimate. And certainly using more rectangles always gives us a better estimate. So those are 2 things we could do to improve it if we needed a little more accuracy here.